Hey everybody, today we're going to be looking at your section 3.4 notes, which goes over the distance formula. Today's notes are going to be pretty straightforward. You're really just going to be using a formula and just applying it to a few examples. So here is your formula right here, where you have D equals, and it's going to be the square root of the change in x, or x2 minus x1, and that will be squared, plus the change in y squared. And you're going to use your points, and this would be your first x and your first y, and then your second x and your second y. You're going to use those points in the equation and use order of operations to get your final answer. One thing is you want to be careful about your negative numbers, because when you end up squaring your negative numbers, remember that you're taking and multiplying a negative by a negative. So you will always end up with a positive once you square them. All right, so let's go ahead and just jump in. This one, example 1, says to use the distance formula to find the distance between 210 and negative 5, 4. So this will be my first x and first y, second x and second y. So my distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, so I'm going to have the second x minus the first x, so negative 5 minus 2, and that will be squared, plus second y minus the first y, so 4 minus 10. So I get negative 7, and I'm going to leave that in parentheses, and that will be squared, plus negative 6, which will also be squared. Okay, I'm going to square each of those, so I get 49 and 36. If we add those together, we get 85. And let's just round to 2 decimal places. So in your calculator, you're just going to find the square root of 85, which is 9.219. So we'll say 9.22. Okay. I am going to also have us look at what to do if we're told the lengths of 2 different things, or 2 different parts. So you can also think of your distance formula as, remember I said that x2 minus x1 is the change in x. So think of this as the change in x squared plus the change in y squared. And another way to think of your change in x is really just what is your horizontal, and your change in y is really what's vertical. So it says find the length of the diagonal of a rectangle if the rectangle has a length of 10 inches and a width of 5 inches. All right, so I'm going to have my width be 5 and my length be 10 inches. It wants to know what the diagonal is, which is the distance from one corner to the other. So I'm going to, for my change in x, it's going to be 10. So that will get squared. And my change in y is 5. So that will get squared. So I'm going to have 100 plus 25. So I get 125. Let's take the square root and round to 2 decimal places. And we also should include the units here. So it would be 11.8 inches. All right. I'm going to have us skip the connect problem. For example 3, it says to find the distance between these points as well as the slope of the line that connects them. So the first point that we have is -5, 3. And the second point is 7, -1. So using that, we're going to find the slope. So I can use the picture here for the slope, or I could use my formula. I can see that it goes down 4, and then it goes to the right 12. So my slope would be -4 over 12, or -1/3. Okay, for distance, I'm actually going to use this as my first x and first y, second x, second y. So I'm going to have second x minus first x, so 7 minus -5 plus -1 minus 3. So for the first parenthesis, we get 12. For the second, we get -4. And you can actually see that those numbers match what I have over here. Next, you're going to square them. So we have 144 and we have 16. Add them together. Take the square root. We get 12.649. So it's about 12.65 away from each other. Okay. On the next page, we have a few examples to help you answer the different questions for this section. So looking at, we'll just do a few of these together. Let's go ahead and look at number 1 is fine. So distance formula. So I'm going to have 0 minus 12 and 16 minus 0. So I have -12 squared plus 16 squared. So I get 144 and 256. Add them together, we get 400. And if you take the square root of 400, it's a nice even number. Okay, let's do one that has decimals, just so that you don't worry too much if you run into one of those. This is my first x and first y, second x, second y. So I'm going to have 1.5 minus 4.5. That will be squared plus 3.5 minus 0.5, and that will be squared. Okay, when I square, or when I find the difference between these, I get 3 and 3. Open this one would be -3 technically. but it'll be okay when we square it, it'll go away. So we have 9 plus 9. So I'm going to take the square root of 18, which is 4.242. So we'll say about 4.24. So with the decimals here, it didn't even make it that tricky of a problem. Okay. For number 7, it wants us to find it in 2 different ways and see if it changes how we get our answer. So let's go ahead and use this point as our x1, y1, and this point as our x2, y2, and see if it changes anything. So I'm going to have 4 plus 2 because of subtracting a negative. And then for the second parentheses, I'm going to get 13 minus 5. Okay, so we have 6 squared plus 8 squared. So we get 36 plus 64, which is 100. And if you take the square root of it, you get 10. All right, let's see what happens when we switch the order. I'm now going to have negative 2 minus 4 and 5 minus 13. So I have negative 6 squared and negative 8 squared. But when I square those, the negatives cancel, and so I am still left with the square root of 100, which is 10. So the difference or the distance between the numbers is the same. So the distance between the points is the same because the difference when we subtract is the same after it is squared. So when we square it, it ends up canceling out the negatives, so we don't have to worry about it. Okay, that next problem, number 8, is just like the one that you did on the last one on your notes. So let's go ahead and look at number 9. It says, if you drive 5 miles east, so let's go ahead and show that. 5 miles east, so you'll be going in this direction, and then drove 4 miles south. So this one is 5, this one is 4. How far are you from your starting point? Round to the nearest decimal place. So we want to know how far we are from the original place. So I'm going to use my change in x squared plus the change in y squared. So I'm going to have 5 squared plus 4 squared. So I have 25 plus 16. So I get the square root of 41. Get 6.403. So let's say about, oh, and it says 1 decimal place. So 6.4 miles. Okay. The next one says, after school, a student drives to her part-time job, and it's located 5 miles north and 4 miles east of her home. All right, so we've got of the school. So we've got her school, and from school, she drives 5 miles north and 4 miles east. Her home is 10 miles north and 16 miles east from the school. So this was from her school to her job, and her home is 10 miles north and 15 miles east of the school. So it wants us to figure out how far her job is from her home. So we want to find what this distance would be. So that distance would be the 16 without the 4. So that would be 12. And then this distance right here would be 10 without the 5. So it would be 5. So we're going to use 12 and 5. So the change in x would be 12 squared. The change in y would be 5 squared. So we have 144 plus 25. We get 169, which is 13 miles. Okay. We're going to skip 11. It's similar to number 10. Number 12 says, if a stretch of mountain road covers a horizontal distance of 2,640 feet and has a vertical drop of 200 feet, find the following. So it first says to find the percent grade of the road. So we're going to use slope. And if you remember, we are just going to take the slope and change it to a percent. So I'm going to have my rise over my run. So I'm going to have 200 over 2,640. And I'm going to just divide that. When I divide that in my calculator, I get 0.0757. And let's change it to a percent. So it would be about 7.6%. Okay, for distance, we're going to have the change in x, or the horizontal change, which was 2,640. That part will be squared. And we're going to do the same to 200. So we get 6,969,600 plus 40,000. Add them together. You get 7,009,600. Take the square root. You get 2,647.564. So we'll round to the nearest foot. So it would be about 2,648 feet. Okay, that wraps up everything for section 4. If you guys have any questions, just let me know.